Hello friends, today I am releasing my two very useful circuits, which I design and build by myself. The story begins with my other project requirement. So before creating a circuit on PCB, I first create a virtual circuit online. It helps me how it works in actuality. After confirming that my circuit will work, I started to design the circuit online. I was almost at the end of my work. Then this site prompted a message to become their member and removed my all work. After this happens, I search for any other software to do that work. Luckily I find one, and also it is free at least for 30 days. Note friends, I did not promoting or recommending this software. So then I designed the circuits on the Altium software. Then I print that circuits on the AA size paper. If I talk about their working, so one circuit is used for turning the load on when it is night, and automatically off the load in the daylight. My friends, this is a very useful thing. This is just the same as street lights, which auto on at night and auto off during the day. Now the second circuit is the opposite of the first circuit. It will auto on the load during the day and auto off the load during the night. Friends, I have posted both PCB layouts on my other account. You can open it by simply clicking on the links in the description. All this process takes me several hours to be completed. So friends, please subscribe to my channel, also requesting you to like and share this video. This favor will be very appreciated and help this channel to grow quickly. Now without wasting any time, let's build those circuits on PCB. So friends, now you can see this is how I printed the PCB layout on the paper. There is another method rather than pasting PCB layout on the zero PCB. If you don't know about zero PCB, so it is a PCB board without any components or circuits on it. Just like what you are seeing in this video. This is a quick solution rather than uploading the Gerber file and then waiting to receive the standard PCB. That method is perfect, but this method is a lot cheaper and simple to make any circuit at home. You can see how easy to make this PCB. We can cut it with a scissor of our desired size. Guys, I have written the dimensions of the PCB size, so you must set that size of the PCB layout before printing. I have cut the PCB layout from the paper and then I will paste that layout on the zero PCB. There is two sides to this PCB layout and we should paste the front and back correctly. Otherwise, we will have difficulties in making the circuit. Now I have pasted the PCB layout on the zero PCB. I will now place all the components according to the PCB layout. Through this method, it is easy to build a circuit. If we build a circuit without PCB layout, so it will be difficult to do that. Making a circuit just by seeing the schematic can be sometimes difficult. Friends, in order to make a circuit just by watching the schematic, demand the complete knowledge of the each and every component. Otherwise, it is not possible to build a circuit directly from the schematic. So friends, first I have placed the connectors, or can we say terminals, on the zero PCB. We can also avoid these terminals and direct solder the wires to the circuit. But it is best to include the terminals in your cart when buying the components for this circuit. So after placing the terminals, I will place the relay. This is a 12 volt and 10 amps SPDT relay. Friends, here I wanted to tell you the most important thing. The load you want to run is fully dependent on this relay. So the relay must be selected as per the load rating. Let me mention here an example. If you wanted to run any street light or anything under 10 amps, then there is no problem with this relay. Now if you wanted to run a heavy load like 1.5 HP water pump, then the relay must be at least 30 amps. Nowadays there are relays available specified for every appliance. So friends, the relay and BC547 are set, and now I will place LDR resistor or sensor. Here I wanted to tell you an interesting thing. The sensitivity of the circuit depends on this LDR. We can change the sensitivity by simply using different values of the LDR sensor. I realized that one component is missing. I have not placed the diode yet. So I will place it on the circuit before soldering. This circuit can work without this diode. But it is good to use it whenever there is a relay in the circuit. Because when the relay turns off, it creates a reverse pulse of very high voltage. That pulse will circulate in the circuit and can damage the circuit components at any time. This diode cancels the pulse by circulating it into the relay coil. So the pulse will not able to flow in a complete circuit. I also put little superglue under each component, so they will not move while soldering. After placing all the components strongly in their place, it's time to solder the PCB. Some components can be soldered directly with each other through their legs or pins. But in some places where it is not possible to make the connection directly with the component's pins. To solve this problem, I will use a thin wire. Thin wire is used to make connections within the components, and thick wire must be used within the load, supply, and relay connections. This circuit is almost completed. I built this circuit very simple without any IC. So now this is not difficult to build. But the other circuit has IC in it. The other circuit is very sensitive. This circuit is used to auto load on during the day and auto load off at the night. The other circuit which I have built in this video, which you will see after this circuit is completed, is used to auto load on in the night and auto load off in the day. Just like in street lights. Now friends, I will show you how it is working. This is a short test of this circuit. I have done a detailed test of both circuits at once at the end of this video. Friends, you can see this circuit is working. It will off when I put my hand on LDR sensor. When I put my hand on the LDR sensor, the light intensity falls and it off the load on a specific decrease in the light intensity. I temporarily use a 3.7 volt battery as a supply and I use 4 volt LED strip as a load. This is a artificial light, but it is working perfectly on this. So it will work more better in outdoor conditions. But to avoid rain or moisture, put it into a transparent box or enclosure. Now we are heading towards the part 2 of this video. Friends, we are in part 2 of this video. I remember you again one more time. In this part I will make another circuit. This circuit is very important and widely used in many applications, such as street lights. So to make such a circuit we need some components which you are seeing on your screens. This circuit is a little complex and a little difficult to build. But I enjoyed building this circuit. Components can be different according to different areas. So I also provided the schematic diagram. Without wasting any time, I will start the process. So just like I built the previous circuit, I will again repeat that process. But this circuit will take a little more time than the previous one. This circuit has much more components and soldering than the previous circuit. This circuit is called the light dependent switch and it is available in the market. But I love to create my own version. And also this will be much cheaper than that available in the market. Guys, I have provided its PCB layout and schematic in the description. You can find that link in the video description. Friends, I am looking forward to some big projects. So subscribe to this channel and also like and share my videos. Without support, further projects will not be possible. I always try to do something different and innovate and invent new things, which has a great impact. If I give one of the examples, so it was my solar power boost project. In that project I made a perfect mechanism of almost double the solar panel's power. No one has ever built such a system so perfectly and so cheap. This is only a tip of an iceberg. Rather than this project, there are many more projects you will find on my channel which will amaze you. So if you subscribe to this channel and also prefer others to subscribe to this channel, I will able to bring more technical hacks and innovations on this channel, which will also help you to solve your problems and learn about electronics. So let's come back to this project. As you can see, I have already started to place the components on according to the PCB layout. This circuit has a little bit more components than the previous circuit. Guys, you will never find these circuits anywhere else, because I have created this. These circuits are the best light dependent switches. They are even better than the market ones. The first reason is obviously these can be built at home for a lot cheaper than the market ones. And second is this is customizable. We can use these circuits for load up to 6000 watts. We just need a relay for 6000 watt applications and we are good to go. Both circuits can control such heavy loads according to light. When I was building these circuits, one thing was very clear in my mind. That was I have to make these circuits easy so anyone can build their circuits. So you can see I make these circuits simple. Now anyone can try to build these circuits at home very easily. These circuits also look cool. This does not seem to be homemade work. So friends, give me some credit for professional work. You can do that just by subscribing to the channel. It gives the channel a support and you get interesting electronic knowledge, ideas, and technology awareness. Come on friends, this is a win-win condition. Let's create more amazing projects. If you have any ideas or suggestions, so comments section is what for. Do a comment under the video so I can know your opinions and thoughts. Now, this circuit is close to its half completion. I am placing the relay on the PCB, but I having a little difficulty to adjust it. So I will use the drill to make the PCB hole customizable. With the help of drill I will solve this problem very easily. Here I repeat one thing, which is that the load is dependent on this relay. This relay is good for light loads like 500 to 600 watts. But in case of heavy load we should need high value relay. That relay can be used for 5000 to 6000 watts of load. So after placing all the components into their places, I will use a little amount of superglue under each component. This will set the components to their places and they never move when I am soldering. I am just going to start the soldering process. After that I will cover the back of this circuit with duct tape. Then we will enter into the test phase. There I have done the testing of both circuits together. Before starting the soldering I will first make the components connections with each other. I will use the components legs and join each other according to the circuit diagram. The use of tweezer and screwdriver will make my work a little easy. But after making a connection like this there will be some of the connections will be left. I will make those connections with thin wires. I will use thin wires to make the connection between components and thick wire to make the connection with the supply relay and load terminals. Friends, I want to talk about some necessary factors which we should keep in mind when we are dealing with electronics and while soldering. In those factors, first one is electrostatic discharge. Electrostatic discharge is the sudden discharge of static electricity between two objects. We routinely encounter ESD in our daily lives. It's that shock you feel when you touch your car door in the dry winter months or when you walk across a carpet and then touch a doorknob. This charge can be in excess of 20,000 volts, much more than it takes to destroy most electronic components. Because of this, preventing an electrical charge from building up is important when working with electronics, since even a small potential can destroy sensitive components. You can avoid building up any excess charges by taking some of the basic precautions such as avoid loose clothing or clothing that dangles down in contact with ESD-sensitive devices. Wear materials made of cotton, rather than wool or synthetic materials. Wear a properly grounded ESD wrist strap and/or heel straps, making sure it is properly grounded. Now here is another most common and most important factor, which is called soldering. There are two commonly known methods of soldering. One is conductive soldering and the other is convective soldering. The most common method is conductive soldering. In this method, a soldering iron is used to make contact with the materials to be connected together. This rapidly transfers heat directly to the area, making this the preferred method of hand soldering. To enhance this process, a heat bridge, composed of a small quantity of liquid solder, is formed between the hot soldering iron and the component. In convective soldering, the air is used as the major supplier of heat. For this, you will need a heat gun or similar tool that blows hot air onto the area to be soldered. This method is a less efficient method of heat transfer due to the inability of air to transfer heat quickly. Because of this, when using convective soldering, you need to be very careful. The longer heat is applied to a board, the more likely it is that you could blister, damage the laminate, reflow neighboring parts, or destroy heat-sensitive components of an electronics assembly like glue, batteries, and plastic connectors. When using a soldering iron, it is important to think about tip selection before you begin. In order to form a properly wetted solder joint quickly, you must use the proper tip for the job. Always use the largest tip available that does not extend off the sides of the pad or land, as it is also called. The proper tip coverage on the solder connection area is 50 to 75%. If a tip that is too small is used, you will not be able to transfer the necessary heat needed to form the solder joint quickly. About 2 to 3 seconds. If a tip is too large, you may damage the laminate of the board around the area being soldered. This is why it is so important to choose the correct tip size. A near fit is not good enough for most applications. When soldering, contact both the lead and the pad simultaneously. This, in conjunction with a properly formed heat bridge, will allow you to quickly solder the part. Before and after soldering, it is important to clean and inspect the solder joint. For a solder joint to be properly formed, the connection area and lead must be clean and free of any foreign materials. After soldering is completed, all flux residues should be removed from each solder connection by cleaning with isopropyl alcohol or another cleaning agent. And then blot the area dry with a lint-free ESD safe tissue. So this circuit is almost done. I am placing the final component in the PCB. This IC is the heart of this circuit. This is the 555 timer IC and it is widely used in common applications. This circuit is fully completed and we are heading toward the last phase of this video. In the ending phase we will see both the circuits working together. I will place both circuits side by side. Then I will apply the artificial light. So these circuits will behave according to specific way. One circuit will on when the light falls and at the same time other circuit will turn itself off and vice versa. Guys, I forget about an important thing. I have not placed the LDR. So now I will place that LDR first and then I will go towards the last phase. This is called LDR. It is a type of resistor but its resistance depends on the light falling on it. There is two type of LDR, one in which resistance decrease with the increase in the intensity of light and resistance increase with the decrease in the intensity of light. The LDR which you are seeing on your screen is the same type. The other type is the opposite of the first. This means resistance increases with the increase in the intensity of light and resistance decreases with the decrease in the intensity of light. The second type of LDR is very rare. I searched it hard, but I did not find it. In the circuits, this LDR sends the light and dark, which send the signal to the circuit. So they will on and off the load. In both the circuits I have used 3 mm LDR. This circuit is very sensitive to light. It off the light on a very less amount of light. If you find any difficulties, you can cover LDR sensor with a half transparent object. I repeat one more time. This current circuit which you are seeing me building is very sensitive to light. So if this circuit is not able to on the load at night, then you can use a half transparent item to cover the LDR. I am saying just because in the case of moonlight can affect the working of this IC based circuit. The second method is by changing the value of LDR. If you have a technical knowledge, so you can change the sensitivity of circuits by changing the values of LDR sensors. So friends, now, this is the last phase of this video. If you are still here, I thank you to bear me for a straight 21 minutes. In this phase I test those circuits. I build those circuits for a reason. I am working on a solar project. So I use these in that project. I will quickly connect the wire with these circuits. For testing I am using 3.7 volt batteries as supply and LED strip as a load. I use a 12 volt adapter as a power source for the circuits. Friends, I did not feel good about this test. This is just a quick check, either they will work or not. Later I will show you their work when I set them in my project. Then it will show a clear picture. Guys, both circuits need different voltage rating to work. One circuit needs 12 volts to work properly and the second circuit needs 9 volts to work properly. I have written the voltages on the PCB layout. I have provided PCB layout link, which you can easily find in this video description. When you see those PCB layout, you will find out what I am talking about. In order to use these circuits in my project, I have done a little changes in circuits. So don't get confused and only follow the instruction which I have provided you on the PCB layout post. I have made all the connections and I am ready to perform a test demonstration. I will use a lamp as a light source. I will turn off my room light so we can see the actual results of the circuits. I will do indoor test with artificial light. So if these circuits works on the artificial light, then they definitely work on sunlight and darkness. This is the more clear picture that how to make connections. So friends, according to plan I switch off my room light and plug in the circuits adapter. But it was not working. At first, I was very disappointed. But after thinking I figured it out. It was not any issue, but the LED strips which I connected as a load was interfering with the circuit sensor, which caused them not to work properly. Then I thought about how I solved this issue. Soon I get an idea. If I put something between the circuits and the LED strips, so this can solve the problem. So I put my small wireless keyboard between the LED strips and circuits. And it works. At this time you are seeing that one circuit is on and the other circuit is off. This is the night on circuit which is on right now. It is working as it's supposed to be work. Now I will turn on the lamp. When I turn on the lamp, the night circuit should be switched off and the day circuit should turn on. So friendly, exactly what is happening here. It means that the circuits are working. I consider it a success. I have invented successfully 2 new circuits. Now I will keep continuing the testing for some time, just to make sure everything is working fine. And to satisfy myself that these circuits are now ready to be used in my project. Guys, you can clearly see that circuits are working. When I turn off the lamp, the night on circuit ons the load within 3 seconds. It means it is working well. Friends, we can use it in the street lights. By using this, any light can be built auto on at night and auto off during the day. You cannot just only use light with these circuits. You can use any kind of load with these circuits. Guys, you can also tell me your opinions and suggestions in the comment section. I am always looking for your suggestions and opinions. It gives me a lot of motivation for my next project. And it also helps a lot in the creation of more important projects. So feel free to share your thoughts, ideas and suggestions with me. Your comments will be appreciated. So hopefully you find this interesting and potentially even useful. And if you like the kind of stuff that I am doing on this channel, please take a second and look at some of my other videos on my channel. I have done some pretty interesting things. But in any case, be safe first. Now we are heading towards the end of this video. I enjoyed a lot creating this project and I hope you also enjoy watching this project. There are also many other projects on my channel. So friends, please subscribe to this channel. Like and share my videos. I try my maximum to give you complete information of my newly built circuits. At the end I say thanks for watching this video and have a good day.